Welcome. My name is Caroline Brehm from Bauhaus Universität Weimar, and today I'm going to present our paper, Multivim Paradigm, Comparing Urban Planning Variants with Worlds in Miniature. In this map, you can see our hometown of Weimar, and right here is our train station. Behind the station, you will notice the site, which might look like a park at first, but is actually vacant land. The city hopes to develop this area into a new mobility hub for the region. There are three options that show how a new bus station, bicycle parking, kiosks, park, and so on could be incorporated into the site. This development would affect the residents of Weimar, and the city wants to involve them early on in the planning process. Based on this local planning problem, we investigate how citizen participation can be supported using collocated social VR. During a previous workshop, we took citizens on a virtual tour of the train station. While this was useful to communicate spatial layouts, it was actually quite difficult to compare the different variants. However, such comparison is important to understand the real impact that the designs can have on the community. How will people get to work? Does the area feel safe and inviting or empty and hostile? In this talk, I present results of our research on how to support this comparison of planning variants in social VR. We were inspired by related work on comparative visualizations that are commonly used in both 2D and 3D. This includes juxtaposition, interchangeable approaches where you toggle or animate between datasets, and slider metaphors, where you swipe back and forth between views. Others exist, such as explicit encoding, where you apply something like an AND operation to the dataset, or superimposition. But we found those first three particularly suitable to the urban planning variants. Like architects who build scale models of their designs from cardboard, we decided to show the 3D models of the designs in worlds in miniature. Similarly, in prior work, WIMs were used for the comparison of virtual environments by Nam and colleagues, and for a VR version control system by Zhang and colleagues. We propose a multi-WIM paradigm, where each variant is placed in a separate WIM, which then can be stacked to spatially align the variants for toggle and swipe, or separated to show them side by side. Let's take a look at our implementation. WIMs can be manipulated, zoomed, and panned. We can then stack the WIMs to compare them either with the swipe mode or by toggling between variants. We then can separate the WIMs for juxtaposed view. Therefore, the multi-WIM paradigm provides three modes for interaction and comparison: toggle, swipe, and juxtaposed. We pose two research questions regarding this multi-WIM paradigm. What are the different qualities of the WIM modes in the context of spatial exploration and comparison? And how do the single user versus multi-user settings influence the perceived suitability of these modes? To investigate these research questions, we conducted a user study with 12 pairs of participants for a total 24 participants. We used a within-subjects design that included both a single-user experiment as well as a multi-user exploration. During the study, we first welcomed each pair of participants to our lab and collected written informed consent. The single-user stage was then conducted with the participants in parallel. Each participant completed 3 trials in counterbalanced order of toggle, swipe, and juxtaposed WIM modes. First, a tutorial taught participants how to use the mode, and then we evaluated our techniques along a task set. These tasks were derived from questions that arise in participatory workshops. For example, participants might need to find certain features. For example, here the user looks for and finds the ambulance. Spatial understanding is evaluated in the landmark task, where participants first memorize landmarks and then recall and mark their locations on a map. Detailed comparison was evaluated in the differences task. Participants also counted which variant had more occurrences of a target, and they compared size and area of targets. Finally, they compared walking distances between 2 locations in the 2 variants. For each task, we recorded the task completion time as well as marker accuracy and answer correctness. We used questionnaires to evaluate the WIM modes, including the system usability scale, overall rating, as well as free text responses on things participants liked and disliked. We included custom items on clarity and frustration, and participants rated the suitability of the modes for each task, as well as gave their overall preference and rationale in free text. We also collected demographics data at this point before moving on to the multi-user stage of the study. Here, participant pairs were asked to collaborate on discussion prompts about the real Weimar train station designs using all three WIM modes. In the closing questionnaire, we evaluated how suitable participants found the different modes for the multi-user setting. We also included co-presence and custom collaboration items. In the following, I will present selected findings regarding our two research questions. Firstly, we expected that the different modes would provide advantages for particular task types. While we observed no difference in the general usability and overall rating, as well as the find and count tasks, we did observe an effect of the WIM mode in the differences task. The landmark task and estimation tasks remained inconclusive. Regarding our second research question, we expected that the WIM modes would be differently well suited to collaboration, and this was confirmed by our findings on the communication about the content, and when comparing user preferences in the single user versus multi-user settings. Looking closer at the usability and rating, we find that all modes achieved good usability scores and high ratings on average. Indeed, a post-hoc Bayesian test showed moderate evidence that the usability and overall ratings do not differ between the WIM modes. We included the landmark task to investigate spatial knowledge acquisition. However, we found no significant effect of WIM mode on recall accuracy, and the same goes for the suitability ratings. While participants completed the recall significantly faster with the juxtaposed mode compared to toggle, faster times do not indicate good spatial understanding, so our findings in this task were overall inconclusive. When it comes to comparison, the toggle and swipe modes seem particularly effective for focused pairwise comparison in the differences task. Participants were significantly faster when using toggle compared to juxtaposed, with a 38-second difference between the means. And user preferences confirm this finding, with both toggle and swipe being rated as significantly more suitable to the task than juxtaposed. Moving on to the multi-user setting, we asked participants to rate how well they could point out content in the variants to the other user, as well as follow discussions about the content. Here, the juxtaposed mode received the highest mean rating, and compared to the toggle mode, this difference was statistically significant. This is also reflected in the user preferences. These shift from the stacked modes, toggle and swipe, in the single user settings towards the juxtaposed mode in the multi-user settings. In the single user setting, participants cited the quality of the interaction for their preferences. For example, toggle made switching between variants very simple, and swipe was most interactive and enjoyable to use to this user. Whereas in the multi-user settings, users pointed out that the juxtaposed view benefited collaboration. For example, I wanted to be able to see both variants at the same time and not be controlled by the other person's decisions. To summarize, in an exploratory user study, our proposed multi-WIM paradigm supported comparison of planning variants. Detailed comparison of differences was best supported by the stacked modes, toggle and swipe, and juxtaposed was preferred for collaboration. We recommend to allow users to switch between the WIM modes because it provides support for collaboration, where users often switch between loose and more tight collaboration phases. For example, participants might first work on comparison tasks individually using the visualization best suited to the task or the one that they personally prefer, and then come together to discuss details, for example, using the juxtaposed WIMs. For further information, please refer to our paper, Multi-WIM Paradigm, Comparing Urban Planning Variants with Worlds in Miniature.